My nanoscale physics group uses electron microscopy to study the fundamental atomic structure of matter in a wide variety of different subject areas. So, for example, in this image here of a layered structure, every dot that you see is an atom. It's either a titanium or a carbon atom. And not only did we discover this structure, we also found that it exhibits intriguing superconducting properties. And this study was published last year on the cover of Science. We also looked at an even smaller type of material, a single strand of atoms, of titanium atoms. And this was published on the cover of Matter also last year. And this study is funded by the National Science Foundation. Not only can we look at the structure, we can also identify the composition, the chemical composition of materials. Here's an example of a solar cell material, cadmium telluride. And you see at the interface, there's this blue layer that looks like a snake of individual atoms, like tellurium atoms. And these atoms are responsible for increasing the efficiency of these solar cells quite dramatically. And this work is funded by the Department of Energy. So another exciting area is the discovery of materials for quantum computing. And our approach here is that we're going to use these tiny particles, so-called quantum dots, as the fundamental computing units for future quantum computers. And these so-called qubits can be packed really densely, as you see there. And the atomic structure in this red and yellow image really governs the properties of the future quantum computer. And here's what a quantum computer looks like today in this chandelier-like structure, right? That's the actual quantum computer. It's probably not what you expected a computer to look like in this day and age. You can also study biomaterials, for example, at the atomic scale. We can look at, for example, at the very early formation of teeth, or we can look at the composition of new kinds of mouthwash. And this will pave the way to eliminating tooth decay and potentially to the regrowth of new teeth in our mouth. Also, we use atomic solution characterization to look at completely new types of material, in this case, a new superconductor that only exists at high pressures. Now, every single spot you saw in those images is really a single type of atom, right? And we can characterize this at the atomic scale, thanks to the unique instrumentation and capabilities that are available here at UIC and were developed in my group. And this all began in 2011 with the first NSF instrumentation grant that allowed us to install a new type of microscope here at UIC. And we set up a user facility that 13 years after its inauguration, where Dean Nelson was there, I have a picture of him cutting the ribbon, still produces high-impact science and theses. We've also developed over the years many new approaches. For example, here a holder that allows us to look at atoms, how they dissolve and get deposited during a battery charging process. And this is thanks to a grant from the Department of Defense that was designated to minority-serving institutions. We also developed machine learning approaches to help us deal with the ever-growing demands on data analysis. And last year, we installed a new type of instrument that allows us to do low-temperature sample preparation, imaging, and even cryo-electron microscopy. And this is what I'm really most excited about, this new instrument that will come here later this year. It is thanks to an NSF grant again and substantial investment from the campus. And this will allow us really to revolutionize the type of characterization we do on campus here for quantum materials, biomaterials, and energy materials. And finally, a plug, if the weather improves, please join us next Monday for the solar eclipse viewing. And the quad on the East Campus here, the physics department and the astronomy club will provide you with glasses to watch the event. Thanks so much.